let's talk about how to use a function generator and oscilloscope in Tinkercad. We will use the circuit as an example. So you can search here to find those equipment. Now let's connect them. It's the same as what we did before. You just connect positive to this resistor here. So this is positive to the resistor. We need to put this 550 ohm resistor 50 and we need another load resistor. We will use 10 ohm as an example. We connect them, then go to negative. Oops. For the oscilloscope, it's the same as the voltmeter. So you connect the positive to the high potential and negative to the low potential. That's the circuit. Then we need to set this function generator to a square wave. It's here in this corner. We select square and set it to a 10 volt peak to peak voltage. One thing I need to mention is in Tinkercad, this amplitude is actually the peak to peak value. I know it's confusing, but I don't know, it's just how they build this website. So here it's set 10 volt peak to peak. We just set it to 10. And the frequency is a 40 Hertz. Set to 40. Oops. And that's it. Then we start simulation. And let's talk about how to read this oscilloscope. We have an instruction here. So let's see. Vertically, we will use this picture as an example first. So vertically, each division is equal to the number on the right divided by the number of the total divisions. So the number on the right is 1 volt and the number of total division is 10 here. So for each square, it's just 1 divided by 10, which is 0.1 volt. And to find the peak-to-peak value of the square wave, we just need to count how many squares does this signal have. So here is 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 multiplied 0.1. Which is 0.8 volt, but it's peak-to-peak value. So for the amplitude, it's just 0.4. And to read horizontally, it will be the time period of our signal. So horizontally, it's the same. Each division is equal to the number on the bottom divided by the number of total divisions. In this picture, it's 100 milliseconds divided by 10 squares. So it's each horizontal division will be this 100 millisecond divided by 10, which is 10 milliseconds. Division depends on the period of the signal. And we already know the signal, the frequency of the signal. So the period of the signal is just 1 over the frequency. And if our signal is about 40 Hertz, then if we set the time per division to 1 over 40, then each division which means each square will have a full cycle. So it will have a full cycle of square wave in one division. Now let's see what does it mean. So this time per division, it's set to 25 milliseconds, which is equal to 1 over 40. Okay, let's start simulation. You can see that each division contains a full cycle of square wave. But if I increase this number to 100 milliseconds, that's too many cycles. I can't even tell it's a square wave or a sine wave. We lost the details. So in order to reduce the density of the display, we need to turn down this value. Let's try to a 10 millisecond. You see, by turning down this value, we make each division contain less time. Thus, it will display fewer cycles. Now, after we adjusting this parameter, we have the best display of our signal. We can see all the details. Now we can start to read the voltage measurement. So as we said, each division here is equal to 4 divided by the 10 squares, which is 0.4. So each square is 0.4, and our signal is about 4, almost 4. We can say it's maybe 3.9. So the voltage will be 3.9 multiply 0.4.